In this video, we'll talk about law of sine. And let's review trig ratios quickly, okay? So if we have a right triangle A, B, C, and each opposite side is called letter A here, uppercase, lowercase b, uppercase, lowercase here. So lowercases are standing for the length of a triangle, and uppercase is the vertex, names of the vertex. So we have a certain way of calling these parts. The longest from this right triangle is always called hypotenuse. That's the name. If we are talking about one angle, if I say this is the angle I'm going to use, angle notation theta, and this is called the opposite side from the angle. And the third side will be labeled as adjacent side to the angle C. So we know sine, cosine, tangent as SOHCAHTOA. That was from middle school. And we learn about secant, cosecant, and let me write backwards, okay? Secant here, and cosecant here, cosecant, and cotangent here. So if we define those as a reciprocal of the function above, this is sine, so 1 over sine theta will be cosecant, 1 over cosine theta will be labeled as secant theta, and we will define 1 over tangent theta as cotangent theta. So we are using 3 basic tricks, and we can expand this idea to reciprocals. So that is the name for the reciprocal functions, and this is 6 basic trig. Okay, so that was a brief review. And law of sine is kind of a relation between length and the angles. So it is like this. Sine uppercase A is the angle over lowercase is the length. The ratio between sine A and A is same as sine B and lowercase b. And it is also same as sine B. I did B, so let's go with sine C over length C. So this is the equation. You have 3 parts, right? You can set up only the equation by using 2 parts. And then you can use cross multiplication to find any unknown part. So this is called the law of sines. We have lots of sines, so it's called the law of sines. Okay, if I have only one sine, I can say law of sine with as a singular. We see sine 3 times, so we can say law of sines. So that's law of sines. So let's think about verifying that, okay? Let's start with the sine A and sine C proof. So if we have this ratio, let's say this is altitude H and opposite side C, opposite side A from the same corresponding angle. So we use the same same variables. So let's start with the special right triangle here. Okay, not special, just right triangle here, and then let's start with the sine A. So sine A here, A, right? Okay, so how do we go in a right triangle? So we can say this is opposite, right? So opposite over let me write definition first. Opposite over hypotenuse. So it goes like this. H over C, right? H over C in this right triangle. And then let's follow the direction. Let's calculate what is sine C. Sine C, where is angle C? Angle C is here. So let's talk about sine. Sine is opposite over hypotenuse again. So this will be H over A, right? That's right. And now let's see. Can I start with the sign B? Okay, but it's not a right triangle, right? So it's not easy to set it up. So let's think about these two. So this is the result like that, and this is the result here. Do we see any common thing? Yes, I see H and H. They are same, right? So can I do cross multiplication? So let me start with the bottom one first, okay? This one all over 1. So we can do cross multiplication. H will be A sine C, right? Like that, the first equation can be written as H equals to C times sine A. C times sine A. So can I equate both of them because both are equal to H? Sure, so let's connect them, okay? So C sine A from the first equation equals to last one, A sine C. Can I rearrange this by dividing both sides by A? Sure. Can I divide everything by C? Sure. So we can divide everything by A and C knowing that both are not 0. And then we can cancel one of the factors like this, and then we can conclude sine A is same as sine A over A is same as sine C over C. So this is the part of the trig equation called law of sines. Sine A over A equals to sine C over C. Similarly, we can do the same way for the other way, okay? So we can draw altitude from C, and then we can compare A and B as the same ratio, and we can expand this two ratio to 3 ratios, okay? So we can verify all ratios between sine A over A, sine B over B, sine C over C. They are all equal to each other. So that is law of sines. So let's do one example together, okay? Number 1, and I will do the question on the left-hand side. Find the unknown size. So this is unknown side, right? Side 8, 12 given. M is not known, so I have M. So find the unknown size and angles of each triangle using the law of sine. So I don't know this angle, right? Okay, so I need to figure this out too. When I use M, measure of the angle M, I must to use the corresponding letter, okay? Opposite side from that. So if I use both of them at the same time, I have two unknowns. So that's not a good idea to start with. So let's see what measure we know. So 80 degrees given, and I have 12 as a number. That's good start. So let's use sine 80 degrees over 12 has the same ratio with what? So let's go with this one. Number 8 goes with angle K, right? So let's go with sine K, angle K, and over 8. So we have the same ratio. So we will do cross multiplication. So let's do cross multiply. So I will do 8 times sine 80. That's multiplication, right? And then we will divide both sides by 12. Okay. And then I'm looking for K value, so I need to use the inverse of the function sine. So I will put this on the calculator, and then we can find the answer. I put everything as together because we are good at cross multiplication. You multiply those and then you get answer, and then you keep calculating, and eventually you are looking for the angle. So we must use second button with the sine button. Okay, so let's calculate. Let me calculate second sine in the numerator, 8 sine 80 degrees divided by 12, and I can get about 41.036 degrees. Okay, so that is the measure of the angle K. Okay, all right, so by knowing this as 41.036 degrees, can you find measure of the angle M? Sure, measure of the angle M will be from and I'm not using trig or the love sign again, okay? I'm going to use the easiest one I can find the answer quickly. What is it? Triangle sum theorem. So 180 degrees and 80 degrees and 41 degrees, right? Is that three? Okay. We subtract all of those and then we can find the answer, right? So yeah, I will use the easier way to get the answer. So that will be about 89.634 degrees. Okay. And when we calculate, it's okay to have a km in pre-calculus class, but actual notation in geometry must be measure of the angle m, measure of the angle k, like that. Okay. So that's the notation little m for measure. And this m is for the length of the opposite side, right? So to do that, I need to use trig sine, love sign once again. So let me use the same love sign. This is given, right? So sine 80 degrees and opposite side 12 has the ratio. That ratio is exactly same as uppercase M and lowercase m. Okay, so I need to use love sign. So this will be going like that. Sine, what measure? We just found this, so we will use that as our number. Okay, I'm carrying more decimals. It's okay to have one decimals, but if you carry more and more decimals, the answer will be approximately better, right? So you can find the measure of the length of LK, which is M. So this will be lowercase m. So we do cross multiplication and then we divide by that and then we can get answer. So to find M, we need to multiply everything and then divide by sine 80 degrees and then we can find the answer. So let me calculate it. Sine 58.964 multiply and then divide by the other ratio sine 80 and then we have number 10.44. So this is the length, low degree notation, and these are angles, so we can find all the parts. Finding all parts of a triangle is called solving triangles. Okay, so we can find all the measures of three lengths and three angles. So that's when we use love sign. Okay,